The story of the universe is written in starlight. It's a tale told across billions of years and honestly unimaginable distances. We read this story using powerful telescopes, looking out into the cosmic dark. But sometimes the most profound secrets aren't found by looking up. Sometimes they come from the most remote and desolate places on our own planet. Deep in the frozen heart of Antarctica, a continent of ice and silence, a strange new mystery has emerged. Scientists have detected whispers from the cosmos, signals that travel through the Earth itself, challenging everything we thought we knew about the universe and its fundamental laws. These signals are not just another discovery, they are a puzzle box, and opening it could change physics forever. Imagine a place so cold and so isolated that it feels like another world. This is Antarctica. It is a land of endless ice sheets, stretching for miles in every direction. The air is thin and crisp, and the silence is broken only by the wind. It is here, in this extreme environment, that scientists have placed one of the most unusual cosmic observatories ever built. They are not looking for stars or galaxies in the traditional sense. Instead, they are listening for the faintest, most energetic messengers from deep space. These messengers are tiny particles called neutrinos, and they carry secrets from the most violent events in the cosmos, like exploding stars or colliding black holes. This frozen continent is the perfect laboratory for such a cosmic quest. Why Antarctica? The answer lies in the ice itself. The massive ice sheet, which can be miles thick, provides a pure and transparent medium. It acts as a giant natural detector. When a high-energy particle from space smashes into the ice, it creates a cascade of other particles, like a subatomic firework display. This brief, explosive event releases a burst of radio waves. These are the whispers our scientists are trying to hear. The ice is so clear that these radio signals can travel for great distances without being disturbed. It's like having a perfectly clean window to look through, allowing us to glimpse the most energetic and mysterious phenomena the universe has to offer from our own backyard. This grand cosmic listening experiment has stumbled upon something truly unexpected. It has detected signals that don't seem to follow the known rules of physics. These are not just faint whispers. They are loud, clear shouts that defy easy explanation. They seem to be coming from the wrong direction and possess energies that should be impossible. This is the kind of discovery that makes a scientist's heart beat faster. It's a clue, a breadcrumb leading us down a new path of inquiry. The silent, frozen landscape of Antarctica may have just revealed a profound secret about the very fabric of reality, a secret that has been waiting patiently beneath the ice for us to find. To catch these ghostly particles, you need a very special kind of detective. Meet ANITA, which stands for the Antarctic Impulsive Transient Antenna. But ANITA isn't a building with a giant telescope dome. It's a high-tech instrument payload carried high into the sky by a massive helium balloon the size of a football stadium. This balloon lifts ANITA to an altitude of about 120,000 feet, or 37 kilometers, into the stratosphere. From this incredible vantage point, high above the thickest parts of the atmosphere, ANITA has a bird's-eye view of a vast expanse of the Antarctic ice sheet below, covering an area larger than the state of Texas. The way ANITA works is both simple and, honestly, pretty brilliant. It doesn't look up at the sky, it looks down at the ice. The payload is covered in dozens of radio antennas, all pointed towards the frozen surface. These antennas are listening, constantly scanning for the specific type of short, sharp radio pulse created when a high-energy neutrino interacts with an ice molecule. The balloon slowly drifts on the polar winds, circling the South Pole for weeks at a time. This allows it to survey millions of square kilometers of ice, patiently waiting for a cosmic messenger to arrive and announce its presence with a fleeting burst of radio energy. It is a cosmic fishing expedition on a planetary scale. Think of it like this. A neutrino from a distant galaxy travels across the universe for millions of years. It passes through planets and stars as if they were empty space. Finally, it reaches Earth and plunges into the Antarctic ice. When it strikes an atom, bang! It unleashes a cone of radio waves that travels through the ice. If this cone is pointed in the right direction, it can exit the surface and travel up towards the sky. High above, ANITA's sensitive antennas are perfectly positioned to catch this signal. By analyzing the timing and direction of the pulse, scientists can reconstruct the particle's path and energy, learning about the cosmic accelerator that created it. For several missions, ANITA has floated silently above the ice, a sentinel in the stratosphere. It has successfully detected the expected kinds of cosmic rays and neutrinos that come from above, proving that the concept works beautifully. It has provided valuable data that helps us understand the most extreme environments in our universe. But during its flights, Anita also picked up something else. It detected a couple of signals that were completely different from the rest. These signals weren't coming from space above. They appeared to be coming from below, shooting up out of the Earth itself. This was the first hint that something very, very strange was going on. The signals that Anita detected were deeply puzzling. They had all the hallmarks of being produced by a high-energy particle, just like the ones scientists were looking for. The radio pulse was strong and clear. However, there was one major problem: the direction. The signals were not coming down from the sky as they should. Instead, they were traveling at a steep upward angle, as if they had journeyed straight through the entire planet. They seemed to have entered the Earth on one side, zipped through its core, and exited through the ice of Antarctica before flying up to Anita's balloon. This is where the mystery truly begins. According to our current understanding of particle physics, this should be impossible. The universe is full of high-energy neutrinos, but they have a very hard time passing through dense matter. While low-energy neutrinos can slip through the Earth easily, the extremely high-energy ones that Anita is designed to detect cannot. The Earth is simply too thick and dense. A high-energy neutrino trying to travel through the planet's core has an almost zero chance of making it through without crashing into something. It's like trying to throw a baseball through a brick wall. The wall will always win. Yet, Anita had detected not one, but two such impossible events. This is what makes the discovery so electrifying for physicists. When an experiment produces a result that directly contradicts a well-established theory, it's a sign that something is missing from our knowledge. The signals were not weak or ambiguous, they were robust. Other experiments, like the Ice Cube Neutrino Observatory buried deep within the Antarctic ice, have also searched for similar events without success, which only deepens the mystery. Scientists have tried to explain the Anita signals using known physics. Could it be a reflection off a hidden layer of ice? Could it be some strange atmospheric interference? So far, every conventional explanation has fallen short. The signals stubbornly refuse to fit into the box of what we know. They are pointing away from the standard model of particle physics, our current best theory of the fundamental particles and forces of nature. The standard model has been incredibly successful, but we know it's incomplete. It doesn't explain things like dark matter or dark energy. The Anita anomaly could be the first crack in the dam, a glimpse of the new physics that lies beyond. It's a tantalizing clue that suggests the universe is far stranger and more complex than we ever imagined, with particles and forces that are currently unknown to us. So, if these signals can't be explained by the particles we know, what could they be? This question has opened a floodgate of exciting and exotic ideas. One possibility is that the signals were created by a brand new type of particle, one that is not part of the standard model. Perhaps there is a hypothetical particle, like a sterile neutrino, that interacts even more weakly with matter than regular neutrinos do. Such a particle could potentially travel through the Earth unscathed before decaying or interacting in the ice to create the signal Anita saw. This would be a monumental discovery, adding a new member to the cosmic particle zoo. Another, even more mind-bending idea is that the signals are evidence of physics from a parallel universe. Some theories, rooted in string theory, propose the existence of a symmetric universe that was created alongside our own in the Big Bang. In this mirror universe, time might run backwards, and particles would have opposite properties. Theorists have suggested that the particles Anita detected could be messengers from this other reality, leaking into our own. While this sounds like science fiction, it is a serious hypothesis that physicists are exploring to make sense of the data. It shows how a single, strange result can push the boundaries of scientific imagination. The importance of the Anita mystery cannot be overstated. Throughout the history of science, progress has been driven by anomalies, by observations that just don't fit. The strange orbit of Mercury didn't fit Newton's laws of gravity, and explaining it led to Einstein's theory of general relativity. Similarly, the Anita signals could be pointing the way to a deeper, more complete understanding of reality. Whether the answer is a new particle, a new force of nature, or something so strange we haven't even thought of it yet, solving this puzzle will undoubtedly teach us something profound about the cosmos. This is why we explore. This is why we build incredible experiments like Anita and send them to the ends of the Earth. We are a curious species, driven to understand our place in the universe. The cosmos is under no obligation to make sense to us, but by asking questions and chasing mysteries, we expand our own horizons. The whisper from the ice is a call to adventure. It reminds us that there are still great discoveries to be made, that the map of the universe is not yet complete. The journey to solve this Antarctic puzzle is just beginning, and its conclusion could very well rewrite the textbooks of tomorrow.